Imagine your day. Now take away your phone, no quick texts to friends, no instant news updates. The world feels very different. This was normal life not long ago. People lived without these digital tools. Information traveled much more slowly then. Life moved at a different, perhaps quieter pace. Think about going to a library. Imagine no digital catalogs to search. Picture banks without any ATMs for quick cash. Life was certainly slower in many ways. Finding specific information took much more effort. Communication across distances was also slow, relying on letters or expensive calls. This was the reality before computers became common. This essay explores the amazing journey of computers. It is a story that starts with simple ideas. These ideas grew into complex machines. Our story of computers begins in the 1800s. An English mathematician named Charles Babbage had a big idea. He was a brilliant and sometimes eccentric thinker. He wanted to build a special machine. This machine would perform calculations automatically. It would solve complex mathematical problems without human error. Babbage designed a machine called the analytical engine. It was a mechanical computer powered by steam. It had an arithmetic logic unit like modern CPUs. It had control flow, using conditional branching and loops. It even had a form of memory to store numbers. Sadly, Babbage never fully built it in his lifetime. The engineering and funding challenges were too great. A gifted mathematician named Ada Lovelace worked closely with Babbage. She was the daughter of the poet Lord Byron. Lovelace understood the analytical engine's true potential. She saw that it could do much more than just calculate numbers. She imagined it creating music or graphics if given the right instructions. This was an extraordinary insight, far ahead of its time. The Second World War created urgent, pressing needs. Governments on all sides needed faster ways to calculate. They needed to break secret enemy codes. They needed to aim artillery accurately. They needed to design new weapons. These critical needs pushed technology forward at a rapid pace. Existing mechanical calculators were simply too slow for these vital tasks. In Britain, a dedicated team worked in great secrecy. They were based at a country estate called Bletchley Park. Their primary mission was to crack German military codes. The German Enigma code was a particularly difficult challenge. Breaking this code could provide crucial intelligence. It could potentially change the outcome of the war. This task required immense computational power for that era. Alan Turing was a brilliant mathematician and logician at Bletchley Park. He played an absolutely central role in this code-breaking effort. He designed electromechanical machines called bombs to help break Enigma. His work was deeply theoretical, exploring the limits of computation. But it also had very practical and urgent applications. Turing's ideas and leadership were instrumental. While Colossus crunched codes in wartime Britain, another giant was stirring in America. At the University of Pennsylvania, work began on a machine called ENIAC. ENIAC stands for Electronic Numerical Integrator and Computer. It was designed for the U.S. Army's Ballistic Research Laboratory. Its main purpose was to calculate artillery firing tables. These tables were essential for accurate targeting. ENIAC was an enormous machine for its time. It filled a very large room, measuring about 1,800 square feet. It used over 17,000 vacuum tubes, which were like small light bulbs. These tubes generated a lot of heat and often burned out, requiring constant replacement. Programming ENIAC was a difficult and laborious task. It involved physically rewiring connections and setting switches. ENIAC was finally completed in 1945, just as the war was ending. It could perform calculations much faster than any human or mechanical device. For example, a calculation that took a human 20 hours could be done by ENIAC in 30 seconds. It clearly demonstrated the immense power of electronic computing. Unlike Colossus, which was specialized for code breaking, ENIAC was a general-purpose computer. Both Colossus and ENIAC were vital milestones. Section 5. The Personal Revolution, Computers for Everyone. After the war, computers remained large and very expensive. They were mostly used by big institutions. Governments, universities, and large corporations were the main users. These machines were complex to operate and maintain. Few ordinary people imagined having a computer in their own home. But some forward-thinking visionaries started to dream differently. They envisioned smaller, more affordable, and accessible machines. The invention of the transistor in 1947 was a crucial step. Transistors were much smaller and more reliable than vacuum tubes. They also used less power. Then came the integrated circuit, or microchip, in the late 1950s. Microchips packed many transistors onto a tiny piece of silicon. These innovations made computers dramatically smaller, faster, and cheaper. This opened the door for the personal computer era. The 1970s saw the emergence of the first hobbyist computer kits. People, often electronics enthusiasts, started building their own computers. In a garage in California, two young men named Steve Jobs and Steve Wozniak founded Apple Computer. They created the Apple I, and then the much more successful Apple II. The Apple II was a relatively user-friendly personal computer. Section 6. Connecting the World, the Internet, and Mobile Age. Personal computers changed how individuals worked, created, and played. But the next truly transformative change connected everyone together. The Internet was not born overnight, fully formed. It started as a US government research project in the 1960s. This project was called ARPANET. Its initial goal was to allow scientists and researchers at different institutions to share computing resources and information. In the early 1990s, a British scientist named Tim Berners-Lee invented the World Wide Web. He was working at CERN, the European Particle Physics Laboratory. He developed key technologies like HTTP, HTML, and URLs. These made the internet much easier to navigate and use for ordinary people. Suddenly, a vast universe of information was just a click away. Websites, email, and search engines rapidly transformed daily life for millions. Then came another significant shift, the rise of mobile computing. Laptops became increasingly common, allowing people to take their work with them. But the real game changer was the smartphone. While earlier smartphones existed, the Apple iPhone, launched in 2007, redefined the category. It put a powerful computer, a versatile camera, and the full internet into our pockets. This was a monumental leap forward in accessibility and convenience. Today, in 2025, we are almost constantly connected. We use mobile devices for nearly everything. Section 7. The Thinking Machines, Artificial Intelligence Ascendant. The idea of creating intelligent machines is an old dream. It has appeared in myths and fiction for centuries. But recently, artificial intelligence, or AI, has made truly astonishing progress. AI refers to computer systems that can perform tasks that typically require human intelligence. This includes abilities like learning from experience, solving complex problems, and understanding natural language. These capabilities are expanding at a rapid rate. We encounter AI in many aspects of our daily lives now. Search engines like Google use sophisticated AI algorithms to find relevant information. Social media platforms use AI to personalize content feeds and suggest connections. Voice assistants such as Siri, Alexa, and Google Assistant understand our spoken commands. AI is also helping doctors to diagnose diseases more accurately. It is even enabling cars to drive themselves, a once futuristic concept. Machine learning is a key component of modern AI's success. Instead of being explicitly programmed for every task, computers learn from vast amounts of data. They identify patterns, make predictions, and improve their performance over time. Deep learning, a subset of machine learning, uses complex artificial neural networks. These networks are loosely inspired by the structure and function of the human brain. Section 8. Beyond Binary, the Quantum Leap. For many decades, digital computers have worked with bits. A bit is the most basic unit of information in computing. It can represent either a 0 or a 1. This is called binary code, the fundamental language of classical computers. But scientists and engineers are now exploring a completely new kind of computing. It is called quantum computing. It harnesses the strange and counterintuitive rules of quantum mechanics. Quantum computers use qubits instead of bits. A qubit, unlike a classical bit, can be a 0, a 1, or a combination of both at the same time. This fascinating property is called superposition. Qubits can also be linked together in a phenomenon called entanglement. When qubits are entangled, their fates are intertwined, regardless of the distance separating them. These quantum properties allow quantum computers to perform many calculations simultaneously. This parallel processing power means quantum computers could solve certain types of problems. These problems are currently intractable for even the most powerful classical supercomputers. This includes discovering new medicines and materials by simulating molecules in detail. It could revolutionize fields like financial modeling and logistics optimization. Section 9, Conclusion: Mirrors of our minds and future paths. The journey of computers, from simple concepts to complex systems, is truly remarkable. It started with mechanical gears and meticulously punched paper cards. Now, we have incredibly powerful devices that fit comfortably in our hands. These devices connect us to a global network of information and people. Some of these machines are even beginning to show signs of what we might call intelligence. This progress is awe-inspiring. Computers are much more than just sophisticated tools or gadgets. They are, in many ways, reflections of human creativity and intellect. They demonstrate our persistent desire to understand the world around us. They also show our drive to shape that world through innovation. From Charles Babbage's ambitious dreams to today's advanced AI research, each step forward was driven by human ingenuity, curiosity, and collaboration. We built these machines to extend our own abilities. The future of computing holds immense and exciting possibilities. We will likely see even smarter and more capable artificial intelligence. We might witness the dawn of practical, powerful quantum computers. These advanced technologies could help us solve some of humanity's most significant challenges. These include curing diseases, mitigating climate change, and exploring the universe. But they also bring profound ethical questions and societal responsibilities that we must address. We need to think deeply about issues like data privacy and cybersecurity.